So picking up where we left off, let's just get to work on these ones. So log base 6 of 36. Well, I think about 36. Could it be connected to 6? Yeah, that would be 6 times 6. So log base of 6 times 6, which, if we use our product rule, we can take those and split them up with addition. So that becomes log base 6 of 6 plus log base 6 of 6. Now if you recall, anytime we have log base b of b, what is that going to equal? Well, think about it exponentially. The base of our output as the exponent equals the input. The only way that works is if it's 1. So that always equals 1, so we get 1 plus 1, which gives our answer of 2. Okay. Now if we type that into a calculator, we'll get that same exact answer. But these ones were designed for you to try to do it without the calculator. Okay. Now 50, log base 5 of 1 over 25. 25 I know is 5 times 5, or 5 squared. To get it out from being a fraction, we would have to flip it, and it would be 5 to the negative 2. So log base 5 of 5 to the negative 2. Another rule is log base b of b to the k is always going to equal k, because we know that that part is 1, so it's going to be added that many times, so it would be k. So my answer would be negative 2. Once again, you can check this on the calculator. Okay, 51 now, log base 2 of 64. Well, how can 64 be connected to 2 to some power? Okay, well, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth would be 32, and 2 to the sixth would be 64. So that's like log base 2 of 2 to the sixth, so once again that's going to equal 6, equals that power. So that answer is 6. Okay, 52 should be easy, those are the same, so that is 1. Okay, 53 and 54 are kind of connected. 4 is like 2 squared. 8 is like 2 cubed. So that's log base 2 of 2 cubed, which would equal 3. Log base 2 of 4, which is 2 squared, would equal 2. Okay. Now there's one more rule to remind ourselves about. If we have log base b of 1, we know that's always going to be 0, because only the 0 power will make something equal to 1 when we switch it around. Alright, so those ones weren't too bad. Now these last ones, it does want us to enter into our calculator. Okay. Now it wants us to round to the nearest thousandth, and I'll show you on the calculator how to type this in a second. So that, remember, is tenth, hundredth, thousandth. So 3 places. Alright, so from your graphing calculator, we either go to the calculate, or we start a new document and hit menu and go to our calculator. Okay. Now there's a few different ways that we can access our logs. Okay. The first would be to type this button, which pulls up this dialog box, and you can see the log is right there. Okay. The other way would be to hit Control, so press down on Control, and then notice these 2 buttons. You've got the natural log above and the regular log below. So regardless of what I do, it'll give me that log. Then I just type in the base and click here and type in our number, and we get our answers. Okay, so once you type them in, it should look like this. Okay, so that I believe was 54, 56. See how I just type them in, rounding to the nearest hundredth, so that would round up to 1.381, and so on, 0.883. Now notice this one, we talked about there's those special rules, right? Log base b of b equals 1. Log base b of b to the k equals k. And log base b of 1 equals 0. So that one, you should have been able to look at that one and know its answer would be 0, but if you weren't sure, you could type it into the calculator. Okay, now I notice we had number 59, which had that natural log. Okay, so I used just the natural log button, typed it in, and notice I got my answer. However, because we know the natural log is log base e, I typed in log base e of 6, and see, you get the same answer because it's the same thing. Okay, so using your calculator, pretty easy, right? So that's what you should end up with when you're using the calculator. Alright, now 61 through 66, we're solving each equation. And remember, the idea is if you have the same logs and they're equal to something, okay, we can essentially get rid of those logs and we would end up with just what's left over still equal to each other, and then we can just solve and we get our answers. Okay, so 61 would 10 would equal b. Okay, if I look at 62, the logs I cancel, so I just get negative 3m plus 10 equals 3m plus 4. If I add 3m, get 10 equals 3m, or 6m, because 3 plus 3 would give me 6, plus 4, subtract 4. 10 minus 4 is 6, equals 6m, divide by 6, and 1 equals m. Okay, it's a number you need it to be to work. 63, those cancel out, we're left with 6 minus n equals n. Add n to both sides, we get 6 equals 2n, divide by 2, and 3 would equal n. Okay, looking at 64, cross those out, we get 3x plus 5 equals 4x, subtract 3x, and we get 5 equals x. Okay, if we look at 65, those cancel out, so just negative 2n plus 5 would equal negative 3n, add 2n, get 5 equals negative n, which divide by negative 1, and negative 5 would equal positive n, and that would be our answer there. Okay, then that last one, natural logs, we cancel out, so negative 5x plus 7 would equal 2x. Add 5x, we get 7 equals 7x, divide by 7, and x equals 1. Okay, so those ones are pretty simple because all you have to do is get rid of the logs because they're the same on both sides. Okay, now the next ones we're still solving, but now it's going to be a little bit more difficult. Okay, so if I look at 67, first thing I want to do is get the log by itself, so I'd add 5. So I'd have log base 8 of v minus 6 equals positive 2. Now, to get rid of this, I switch it to its inverse, the exponential version. So the base would be 8. This 2 would be our power, would equal v minus 6. 8 squared is 64, equals v minus 6, add 6, and 70 would be equal to v. Okay, if we look at 69, first thing I would do is divide both sides by 8. Okay, that would give me the log base 3 of 7v equals 32 divided by 8 is 4. Then switch it to exponential, 3 to the 4th equals 7v. 3 to the 4th, well, 3 times 3 is 9, times 3 is 27, times 3 is 81. So I get 81 equals 7v, divide by 7. And 81 divided by 7 would equal v, which 81 divided by 7 gives us about 11.5714. Said round to the nearest 10,000, so that's 4 places behind the decimal. That's where we go. Alright, now let's take a look at 68. 68, we would subtract the 6. Notice that this is in parentheses, this one isn't. So we start by subtracting the 6. So I get log base 6 of negative 9x equals negative 1, because 5 minus 6 is negative 1. So 6 to the negative 1 would equal negative 9x. Okay. So 6 to the negative 1 is really like 1 over 6 equals negative 9x. We divide that by negative 9, and we get x equals, now we just use the calculator. So I could go 6 to the negative 1 divided by 9. Okay. Or 1 divided by 6 divided by negative 9. We end up with Oh, not divided by, is it divided by negative 9? Yeah, it is. So we'd end up with negative 1 over 54, which would be not what I thought it would. Hold on. Would be about, x would be negative 0.0185. Okay, very small number. Okay, 70, we divide by negative 3 on both sides. So we get log base 2 of 2p equals negative 2. 6 divided by negative 3 is negative 2. So 2 to the negative 2 would be equal to 2p. Divide by 2. And we'd end up with, basically 1 over 8 equals p, I think. So 2 to the negative 2 is 1/4. Divide that by 2, and we get 1/8, which as a decimal equals something that my calculator doesn't want to give me. 0.125. Alright? Okay, we're nearly there, aren't we? So, 71 through 74 wants us to solve each equation. Okay? So we're going to have to use this to help us out with that, because log base 4, those are being added together, so I can go negative 5 times x times 7, which would be negative 35x. So log base 4 of negative 35x would equal log base 4 of 65. Okay. Now log base 4's can get removed, so negative 35x would equal 65. Divide by negative 35, and we get x equals, we can either reduce it as a fraction and get negative 13 over 7, or as a decimal it would be negative 1.85714, about negative 1.86. Okay, so let's take a look at 72 now. So 72 now has a minus, so it would be log base 9 of 3x minus, or divided by 2, equals 1. Okay, now, oh crap, we can do this differently, can't we? Or can we? Would that make sense? Well, we could do it that way. Okay, then there's kind of two options we could go here. I could try to make it a power, so an exponent, so 9 to the first would be equal to 3x over 2. 9 to the first is just 9, times by 2, we get 18. 18 would equal 3x, divide by 3, we get 6 equals x. Okay, that's one way we could do it. The other way would be to realize that this, I could combine it like this, or I could add log base 9 of 2 to both sides, and I'd get log base 9 of 3x equals 1 plus log base 9 of 2. Well, 1, didn't we realize that's the same as log base 9 of 9 plus log base 9 of 2, which I could combine using the product rule, so I'd have 9 times 2, which would be 18. So log base 9 of 18 would equal log base 9 of 3x. Cancel those out, and then we just end up with that equation, which reduces to that. So often there's more than one way you can take a look at solving these. Okay, let's look at 73 now. So we could approach this one various ways. Okay, I'd probably combine those, so I'd have 2 times x minus 7, which would be 2x minus 14 if I simplify. So log base 4 of 2x minus 14 equals 2. Then I would switch it to an exponential, so 4 squared equals 2x minus 14. 4 squared we know is 16 equals 2x minus 14. Add 14 to both sides. We'd get 30 equals 2x, divide by 2, and 15 would equal x. Okay? Now if we look at number 74, so it's got log on this side, so I'm eventually going to want to probably simplify this. So 7, so it's kind of like that one, isn't it? the one over here. 7 times negative 5x would give me negative 35x. This would be log base 4 of negative 35x equals log base 4 of 33. Those cancel. We get negative 35x equals positive 33 divided by negative 35. And x would equal, I can either leave it negative 33 over 35, or I could type it into my calculator. And I would get 0.942857. Okay, either one would work. All right, last 6 questions. So now we want to solve these exponential equations. Okay, so we could try to guess and check, or we can use the calculator how we did here. Okay, to do that, so I just change this to a log. So I'd go log base 8, because my base stays my base, of 73 equals x. Now I just type that into my calculator, and it'll give me my answer. Okay, which I'll do in a second. 76, same idea. Okay, I'd go log base 15, so we're essentially just rearranging them, of 44 would equal n. 77, log base 18 of 14 would equal x. Okay, 78, log base 6 of 13 would equal n. 79, log base 17 of 14 would equal n. And then finally, 80, log base 11 of 45 would equal n. So then I just type those into my calculator, and using that, I can get my answers. Okay? So that's what we will do. So when I type these into my calculator, we end up with 75 right here, 76, 77, 78, 79, and 80. And those are the answers. And it says to round to the nearest 10,000th. So we have tenths, hundredths, thousandths, 10,000ths. So 4 places. So I'd round right there. Remember, if it's 5 or above, round up on the previous. If it's not, leave it how it is. Alright guys, so quite a bit of work there. But that's our answers, and hopefully we're able to get a lot of practice in, so you'll be better off doing this kind of stuff. And there we go.